Okay, so this, I didn't realize I was going that long, but in this next video, I'm going to show you quickly. If I do this reduce integration, where I'm going to slightly modify this file. Okay, so I'm going to instead of doing it sloppily, I'm going to say let's save this file, pull one, rename, and I'm going to rename it to something else. Also, save. Let's make a new file rather than this. Copy this. So I'm copying exactly the same file. I'm actually going to give it the same file name to a large extent. The only difference is I'm going to have pull one clamped left. Okay, so that's all I'm going to do, and I'm going to bring back those. So that was a reminiscence from last year's file. That's why it was. So I'm going to clamp each of those nodes on the left image. Okay, so what I'm doing now is I'm doing the following. I'm saying let's model this not with rollers there, but every point now being clamped. This is clamped, this is clamped, this is clamped. Node 1, node 6, and node 11. All of them are clamped in X and in Y. Okay, that's what I've done here. And let's make them leave the magnification factor 1, and I'd say we call this file just as a reminder clamped left. Okay, so let's make it clamped left. Where's this? Clamped left. Okay, and if I do this, look, all of a sudden, this is now my reduced integration. Look at this. Let me just make it the magnification factor of 1 first. Let's just run it. Where's my clamp left? Yeah, reduced integration Q4, clamp left. Look at that. It doesn't look crazy. Yeah, it doesn't look conspicuous. These deformations. If you make it now magnification factor of 10, it doesn't look conspicuous like anything ad hoc there. If I make it 100. Now I start seeing some stuff, but I had to do some investigation. At first glance, everything looks hunky-dory. The stresses are not 10 to the 17, but the stresses are here, 5,000s, 4,000s. And although it's going down to the left of the edge, it's definitely not around 25 MPa. And so can you see here, I've just taken the same problem, and I've just changed the boundary condition slightly, where I constrain it slightly more. I'm getting stuff that looks a lot more reasonable, but it's still wrong. Okay? So this is really how easy it is to have chaos with finite element method if you don't know what you're doing. So bottom line is, whenever you do finite element method, you will verify and have a ballpark answer what you expect to see. And if you deviate significantly from that, you have to be able to explain what's going on, or double check that you didn't make a mistake on the finite element method. Because again, it's so easy to put something in this file where you forget a 0 or have an extra 0 or something like that. So making a mistake is really, really simple. And the reality is, the answers just keep coming. It's not like the program is stopping and saying, I'm not going to give you an answer which is going to be wrong. It keeps on generating answers. And that is really what's important to understand. When we want to apply the finite element method in a sensible way, in a modern era, we have to be able to apply appropriate filters. And say which things are right and which things are wrong. That is really important to understand. So hopefully this gave you a good idea. So we're going to continue this kind of discussion about deformation modes and strain energies as we go along. But luckily now we know exactly what it means. And it's your job now to go and say, let's go back to the 1D bar element that we did. And let's do reduced integration there and see how many eigenvalues are 0. And which ones are they associated with? What kind of deformations are they that has 0 strain energy associated with them? Okay, so hopefully this gives you a good idea and make you aware of the fact that there are something like what's called communicable modes. There are 0 energy modes that can propagate like this, these kind of hourglass and patterns, and that's that. Later on, I'm going to look again at Q8 elements, each full and reduced integration, and see, but why did this not actually propagate? The reality is this one didn't propagate because it has 0 energy modes associated with things that you would not expect to have zero energy modes associated with, but they don't necessarily, they're not able to propagate with the Q8 element as with the Q4 element. So here, I just wanted to show you this nice hourglass pattern. You can see beautifully that deformation, zero energy, strain energy associated with it. Okay, we'll continue tomorrow this discussion. Thank you.